Hello students, welcome to my YouTube channel, PhysicswithS.Msir. And if you are new to this channel, please do not forget to press the subscribe button. And as well as if you like the content of the video, please do not forget to press the like button, because this will give more motivation and I will try to bring more videos for you for your help. Correct? So today's I am going to continue the refraction of light at plane surface. Okay, so let's start the topic. If you have not watched my previous video, please follow the link is given below. Please look at that first, and then you can able to follow this video more properly. So in the last video, I have shown you what is relative refractive index, what is denser medium, what is rarer medium, and why light bends towards the normal, why light bends away from the normal, why not light bends if it falls normally on the separation of two media, etc. So let's start with a problem first, okay, regarding those concepts. So first of all, say for example, this is surface of separation of two media, and this is the normal drawn. Okay, and a ray of light falling like this. Now you people are quite smart, and if you already watched my previous video, you understood which medium is rarer and which with respect to which medium, correct? So say for example, here it is given this medium 1 and this medium 2, and light is falling on this medium at an angle of incidence, say for example 45 degree, and this angle is supposed to be 30 degree. Your question is to find out what is the value of mu1, that means relative Ri of medium 2 with respect to 1. Okay, so what will I do here? We'll use simply Snell's formula, correct? That is sine of I by sine of R is equal to mu 1. Now what is I given? I in this case is angle 45 degree. And what is R? 30 degree. Always remember, you have to maintain that angle which the ray makes with the normal, correct? Now in this case, sine of 45 degree by sine of R means sine of 30 degree, and that is mu 1. What is the value of sine 45 degree? It is 1 by root 2. It's from sine table. We know that sine 30 is also equal to half. So that is mu 1 2. Therefore, mu 1 2 is equal to 1 by root 2 into 2. That is it clear? So this is the technique of solving this kind of sum. Okay. So let us try another problem. It will be different from this, correct? Okay. Now, it is given that, say for example, this is the normal, and light falls like this. And one part of this light gets reflected back into the same medium, another part gets refracted. Okay. Now, say for example, this is I. Okay, and this is R. And what we know, angle of incidence equal to angle of refraction. The question is, write a relation between I and relative refractive index of medium 2 with respect to 1, that is mu 1, 2. Assuming this is 1, this is 2. And condition given, write a relation between I and R, that is relative refractive index and of the medium 2 with respect to 1, when the reflected ray and the refracted ray makes an angle 90 degree with each other. That means in the question, it is given this angle is 90. Clear? So you have to establish a relation. So what to do then? Look at this. If you follow this diagram, let me use a different color so I can give you a clear understanding. If you watch this is a straight angle, correct? This angle is 180 degree. And intermediate angle is 90. So what we can write? Angle I plus angle R plus 90 is equal to 180. Is it clear? If it is so what we can write? I plus R equal to 90. Therefore, R equal to 90 minus I. R equal to 90 minus I. Now, apply Snell's law. What is that? Sine of I by sine of R is equal to mu 1, 2. Now, sine I is this. What is sine of R? Sine of 90 minus I. And if it is that, so we can write it sine of I by cosine of I is equal to mu 1, 2. And we know sine I by cos I is tan I. So we can write it, therefore, tan of I is equal to mu 1, 2. So this is the relation. Is it clear? It's a very important type of sum. Okay. Okay. Now I'm going to tell you what do you mean by absolute refractive index of our medium. Correct? Look, the topic is now absolute refractive index. Okay. Now, when light moves from air to any other medium, vacuum or air to any other medium, that means we can say the relative refractive index of a medium with respect to air or vacuum is called absolute refractive index of that medium. Look, the refractive index, the relative refractive index of a medium with respect to vacuum or air is called the absolute refractive index of that medium. What is the technique of writing this? Say, for example, I'm trying to write down the absolute refractive index of medium 2, correct? So look at this. Absolute refractive index of medium 2. We should write it like this. Only mu and 2. That's enough. We don't have to mention anything in superscript, correct? So this is enough. So what is the definition? Mu 2 is equal to the relative refractive index of a medium with respect to vacuum or air is called absolute refractive index. And we know 1 mu 2 is defined as ratio of the speed of light in medium 1 to ratio of the speed of light in medium 2. And in this case, the light is coming from air or vacuum to the another medium. So in this case, what should we do? We replace this V1 by the speed of light in vacuum or air. That is C. That is C. And if I assume the absolute speed of the light in the medium 2 is, say, for example, V2, correct? So we should write it like this. And what we know, the speed of light is maximum in vacuum or air. So C is always greater than V2. Since C is always greater than V2, this ratio is always greater than 1. So mu 2 is always greater than 1. So remember, it's a very, very important thing. Absolute refractive index of medium. Absolute refractive index of a medium is always more than 1. If by chance you obtain the value less than 1, so please check your answer. It is not correct. Correct? Please check your calculation then. So what we do, we write it like this. So if suppose mu is the absolute refractive, if mu is the absolute refractive index of a medium, is the absolute refractive index of a medium, then we should write the general formula as mu equal to C by V, where V is the speed of light in the medium. Okay. So this is the formula for absolute refractive index and what we mean by absolute refractive index. Now I'm going to show you a very, very interesting thing. How to obtain a relation between relative and absolute refractive index of mediums, correct? So let me do it. Relation between relative and absolute refractive index. Now look at this. What we know, mu1 2 can be written as V1 by V2. This we know. Now what I am doing, I am dividing and multiplying this result by C, that is speed of light in vacuum. Now what I can do, I can write it like this: C by V2 by C by V1 by using simple mathematics. So mu1 2 is equal to C by V2, and as I told you this, C by V2 denotes the absolute refractive index of the medium 2. That is C by V2 is mu 2, and this is by 1. So remember, 1 mu 2 is equal to mu 2 by mu 1. Suppose absolute refractive index of 2 medium is given, and we have to find out the relative refractive index. You can always use this formula. Correct? Now, what is the advantage of using this formula? Look at this. Now I'm going to tell you something which is very, very important. This is called general form of Snell's law. Okay. Now, what is that? From Snell's law, what we know, sine of I, sine of R equal to mu1. Now replacing this mu1 2 by mu2 by mu1. So what we can write, sin I by sin R is equal to mu2 by mu1. Therefore, mu1 sin of I equal to mu2 sin of R. Okay, this is called general form of Snell's law. What is the advantage of this? Let me show you something. According to this, say for example, take a diagram first. This is the normal rod. A light is moving from this medium to this medium. Okay. Now look, what to do then? This is I, angle of incidence. This is the angle of refraction. And this is mu1 and this is mu2. That means this is the absolute refractive index of medium 1 and this is the absolute refractive index of medium. So what to do? Refractive index, absolute refractive index of this medium multiplied by sine of the angle of incidence is equal to absolute refractive index of the second medium multiplied by sine of angle of refraction. Is it clear? This is the technique of applying this formula. Is it clear? Now let me show you a problem related with this. Correct? Okay. Let me tell you. Let's take a problem first. Question is this. Light is moving from medium 1 to 2. Okay. And absolute refractive index of medium 1 is, say for example, take an arbitrary example, 4/3. Okay. And absolute refractive index of medium 2 is, say for example, 5/2. Okay. Find the relative refractive index of medium 2 with respect to medium 1. So what is that? Now look at the solution. What we know, mu12 is equal to mu2 by mu1. Mu2 by mu1. What is mu12? Mu12 is the relative refractive index of medium 2 with respect to 1. Mu2 is the absolute refractive index of medium 2, and mu1 is the absolute refractive index of medium 1. So what we can write, mu12, mu2 is, look, it is given, absolute refractive index of medium 2 is given 5/2. So you should put it 5/2. And what is the absolute refractive index of medium 1? That is 4/3. So it is 4/3. So now do 5/2 into 3/4. What is that? 5 3s are 15 by 8. You can write it in the form of, say for example, 15/8 equal to, you can find out the answer in decimal. Okay. So this is it. Now, I think the concept is clear. Now, what is the absolute refractive index? What is the relative refractive index? If absolute refractive index is given, how to find out the value of the relative refractive index? Correct. Now, take another example. For example, it is given. Okay, let's draw diagram first. Light is moving from medium 1 to medium 2. Watch this very carefully. Light is moving from medium 1 to medium 2. Okay. So, question is, be careful. Huh? Look at the question carefully. Suppose it is given key the absolute refractive index of this medium is, say for example, 3/2. And absolute refractive index of this medium is, say for example, not given. Absolute refractive index of the second medium is not given. Instead of that, it is given that it is I. It is given, say for example, 30 degree, correct? And it is given 45 degree. Clear? So, what to find out here? Watch this carefully. You have to find out the absolute refractive index of medium B. The question is, what is mu2? So, what to do then? Now apply this formula, which is better. Mu1 sin I equal to mu2 sine of R. What is mu1? Mu1 is given 3/2. This is mu1. Huh? Now, mu1 is 3/2. Sin I means sine of 30 degree. Mu2 is unknown. What is sine R? Sine 45 degree. Now 3/2 sine 30 is what? Half. Mu2 sine 45 is 1/√2. Now please simplify this. Mu2 is equal to 3/4 multiplied by √2. If you cancel this, okay, 3 into √2, 4 means 2, and 2 into 2, which you can write √2 into √2, √2 get cancelled. Correct. So we can write the answer in this way: 3/2√2, or simple 3/4. This is more prominent answer because it is in rationalized form. Correct. So this is it. Is it clear? Now, this is another trick. So what is that? I am going to show you, if mu12 is given, how to find out 2 mu1. Okay. So for that, you have to learn a very, very important concept called principle of reversibility of light. Okay, reversibility of light. So what is the meaning of reversibility? Principle of reversibility. The path of light is always reversible. If I made any mistake in spelling, please ignore that. Okay. Okay, the path of light is always reversible. So let me give you a clear understanding of this. What is the meaning of that? Suppose this is a medium, surface of separation of 2 medium. A light is falling like this. Clear? And this is the normal drum. And this is the path of the refracted ray. Now, what I'm doing here, a slight changes, correct? So what changes I am doing here? Please follow it carefully. I am placing a mirror on the path of the refracted ray and placing the mirror in such a manner that the refracted light falls on the mirror normally. That means angle of incidence is 0 degree. And what we know from the concept of reflection, that if a light falls on the reflecting surface along the direction of the normal drawn, it moves back or it retraces its path, correct? That means if it comes like this, it will also go like this. So what will happen? Same thing will be here. I'm showing the backward path by the black lines, correct? Is it clear? Now I'm going to apply the laws of refraction. Clear? For that, what I'm doing, suppose this is medium 1 and this is medium 2. Okay. And here it is applying the laws of reflection for the first one. Correct? When light is moving from there to the inside. That means for the red arrows, correct? That is sine of I by sine of R. We can write it like this, 1 mu 2. Let me make it this equation 1. Now following the black lines, correct? So that means light is moving now from medium 2 to medium 1. So what should I write? Now R is the angle of incidence and I is the angle of, R is the angle of incidence and I is the angle of refraction. So we could write it like this, sine R by sine of I, that is equal to 2 mu 1. Okay. Now I'm going to do a very interesting thing. What I'm doing, sorry, I made a mistake with that. Okay. This is I. Now what I'm going to do, I'm going to divide this two. If I divide it, I'm not going to divide it, I'm going to multiply it. Okay, so if I do the multiplication, that means if I write it like this, if I multiply equation 1 with equation 2, so what we can write, look, or we can do another thing. Instead of doing this, I can do this thing also. I am writing now this as sine I by sine R, which is equal to 1 by 2 mu 1. Now look, if you check the equation 1 and equation 3, left hand side of both of these equations are sine I by sine R. If I equate them, what we can write, 1 mu 2 is equal to 1 by 2 mu 1. This is a relation which is very, very, very important for everyone. Is it clear? 1 mu 2 is equal to 1 by 2 mu 1. Is it clear? Now, let's take a problem related to this, correct? Say, for example, it is given the absolute refractive index. Okay, not absolute refractive index. The relative refractive index of medium 1 with respect to medium 2 with respect to medium 2 is X, and relative refractive index of medium 2 with respect to 1 is y. Find the relation between x and y. Okay. So it's a very simple one. What to do? As I told you, according to the problem it is given, mu12 is x and mu21 is y. And just now I had shown a relation to you. Mu12 can be written as 1 by 2 mu1. Is it clear? So if I put this value x, this is y. So what is the value? X multiplied by y is equal to 1. Clear? These are the typical type of things, correct, which I'm showing you for your standard, correct? Clear? Because you are learning this first time, or means the concept is not so good. So I'm trying to make your concept little bit fast, correct? Now, let me give you a very important concept. That means the concept of lateral shift. What do you mean by lateral shift? Lateral shift is not a deviation. Okay. So let me show you this with the help of a diagram. Suppose this is a rectangular glass slab. Okay. This is a rectangular glass slab. Clear? And say, for example, it is medium 1, it is medium 2, it's a glass, for example, and this is again medium 1. A ray of light is falling on the interface of the air glass interface. Interface means separation. Say, for example, with an angle I. Okay. Now, glass is always remember, air is the speed of light is maximum in air. So obviously medium 2 is denser than medium 1. So what will happen when light enters the medium 2? It will bend towards the normal. Correct? We have done already. Now, what to do? Again, draw a normal. Because it is very important to draw the normals, because in order to make the calculations, we require this. Correct? Now, what will happen? Light is moving from medium 2 to medium 1. That is again from denser to rarer medium. So it will bend away from the normal. Okay. So this is the path. Okay. So let's mark it first like this. So this is I, this is R. And since this is a rectangular glass plate, that means these two sides are parallel. Obviously, these normals are also parallel. So if this is R, we can write this also R. And this, what is E? E is called angle of emergence. Okay. That means the angle with which light is emerging. Correct? Emerging. So now apply the Snell's law. Light is entering from medium 1 to medium 2. So what we do here, we should write it like this. Sine of I by sine of R is equal to mu 1, 2. This is equation number 1. And now here it is. Look, for the second refraction, when it is coming from 2 to 1, what we can write it? Sine of R by sine of E, that is equal to mu 1. Okay. And what I'm doing here, as we know, the relation between 1 mu 2 and 2 mu 1 is this. We can write mu 1 2 is equal to 1 by 2 mu 1. So I'm going to apply that relation in this case. So mu 1 is what? Sine of I by sine of R. 1 by 2 mu 1 means what? If I reverse it, this will be sine of E by sine of R. So what we can write? Sine of I equal to sine of E. Clear? Clear? So I in this case not equal to, look, I equal to therefore sorry, E. Okay. That means what? This angle of incidence and this angle E are equal. That it means what? Look, the thing is this. Look, if I draw this, extend this line. If I extend this line, that means this line and this black, this red, emerging red line and this black line are parallel. That means in this case, no deviation is taking place. Only shifting is there, correct? That means light is shifting its path. Look, it is the original direction, it is the direction is set. But only the changes is it shifted its path, correct? Which is what we call lateral shift. Okay. So now I'm going to show you how to calculate the value of the lateral shift. Okay. Now, let's take this is the lateral shift. Okay. Now, let's name this A. This point is B. This point is C. This point is D. And this point is suppose N. This point is suppose M. This point is suppose M, etc. Okay. Because we don't require it. Now, what I'm doing, I'm going to show you the calculation to find out this shift. Let me denote this shift by X. I'm taking the thickness of the slab, that means thickness of this glass slab or any kind of transparent slab is supposed to be T. Okay, it's supposed to be T. Okay, now look at the conception here. What I'm doing, look at this. Look, here I need ideal geometry as well as trigonometry, correct? So first of all, I am choosing this triangle. Okay, let me change the color of the pen. Wait a minute. Okay. Look at the diagram. I am choosing the triangle BDC. Okay. Now, in this triangle, what I'm doing, look, if this I, this R, so this is what? I minus R. So if I apply trigonometry, this is 90 degrees, correct? So if I draw a triangle, remember, and if this angle is theta, always remember in trigonometry, the angle theta, if it makes always means this theta always we consider with the base and hypotenuse, correct? So this must be the hypotenuse one, this would be the base, and this is the height. Always this is the concept, correct? So I'm going to use this concept. Look, here if I choose this angle, so we must consider BD as the base and BC as the hypotenuse and AX is the height. So CD by this line BC, that means look, height by hypotenuse, which we can write as sine of I minus R. Okay. Now we know CD. Let's write it X because we took this X and this should be BC sine of I minus R. Okay, let's make it equation 1. Now I'm taking another triangle, correct? Look, choose this triangle BCN. Triangle BCN. Okay. Now in this triangle, what I'm doing, look, what is the thing? Because BC is unknown to me and we need to find BC. Look, BC in this triangle, same as hypotenuse. But in this case, look, T is known to us, correct? What is that? That is the thickness of the glass slab. So if I consider this triangle, if I choose this as the angle, so BN is the base and BC is the hypotenuse, correct? So what we can write, base by hypotenuse, that is BN by BC is equal to cosine of R, cos of R, okay? Now, BN is what? Thickness by cosine of R is equal to BC. Now simple. What I'm doing? Now I'm going to put the value of BC from equation 2 in equation 1. If I do that, X equal to, if I replace this BC, by this one, so this would be T by cosine of R sine of I minus R. So this is the relation between the lateral displacement, and you can easily find out it if I is known, R is known, okay, thickness is known. Say for example, it is given key I is, say for example, 60 degree. R is given, say for example, 30 degree, and thickness of the glass slab is given, say for example, 5 centimeter. We have to find out X. So what to do? Simply use this formula. X equal to T, what is that? 5. Now we have to convert this in meter, correct? So it's better, 10 to the power minus 2. Or we can do it in centimeter also, correct? No problem. We can do it in centimeter also, no problem, correct? As you wish, correct? 5 sine of, by cos of R, cosine of R means what? 30 degree, cosine of R. Okay, sine of I minus R. What is that? I is 60 degree. What is R? 30 degree. So 5 by cosine of 30 degree and sine of 30 degree, which we can simply write tan 30. Okay. And what is the value of tan 30? Tan 30 is equal to 1 by root 3. So the answer is 5 by root 3. If you want, you can rationalize it, multiply it with 3. So this is the answer is 5 root 3 by 3 centimeter. Is it clear? So it's my next video. I'm going to show you what will happen if instead of a single slab, if you put multiple slab, and if you instead of instead of using a single slab, if you use multiple slab, what will be the relation between the refractive index, how to find out that, and the concept of apparent depth, real depth, etc., and problem on that, correct? So that's all for today's lecture. Please follow my next video. Okay, do not forget to subscribe to the channel and please press the like button.